Yeah. Yeah. Not yet. Ty's got it. No, Liz got it. Yes. Got it. Oh, what was the formula for circumference? 2 pi r. Circumference equals 2 pi r. Okay, that'll come into play. That'll come into play. Catherine, you got it?
I don't think so.
You got an answer?
Not really.
No, don't want to share it. Kristen,
I'll throw it out there.
let's throw it out there.
1,080.
A bunch of others got that too. Problem with that is that only works when your angles and radians. Okay, so it doesn't work. And I'm not going to use radians just yet. I'm just going to kind of use the fact that the circumference of a circle is 2 pi r. Now your answer should be 6 pi. If you got that, you're right. Okay. Now the whole circumference is 2 pi r. Well, we don't have the whole circumference. How much of the circumference do we have? Got 1/3 because we got 120 degrees. So your arc length is going to be whatever that angle is divided by 360 times the entire circumference. So hopefully that makes sense now. So that angle divided by 360 kind of gives you the fractional part of the circle we have. We got 1/3 of it, and we're going to multiply it by the whole circumference. So I got 120 over 360 times 2 pi times 9, which is 1/3 times 18 pi, which is 6 pi. Now I'm going to show you how to do it the other way here in a minute. But right now, we're just going to leave it at that. That's 6 pi. All right, any questions on homework? Any questions on homework? What'd you get for 57? What'd you get for 57? I think that's one. Yeah.
Where's that? I do. Okay, but where did it end up if you started at 17? It didn't end at 69, only at 67.
It should have ended at, I thought I checked it.
No, did I mess up?
You messed up. You messed up. 57. So you got an answer for 57?
4 pi over
Oh, wait.
4 pi over 3. Did somebody get something different? Better we'll admit it. What'd you get?
960 degrees.
What? Okay. Here's where, I'm glad you admitted it though. Here's where I believe it's 16 pi over 3 is the original one, and they want a coterminal angle between 0 and 2 pi. So if it's in radians, you got to keep your answer in radians. So I'm glad you said that. What do we got to subtract? We got to subtract 2 pi. So 16 pi over 3 minus 2 pi. Well, that is 6 pi over 3, which gives me 10 pi over 3. Well, why isn't that the answer? Okay. I mean, we haven't done anything wrong. It's not the answer because it said it wanted an angle in the interval 0 to 2 pi. That is not in that interval. Okay. So our final answer has to be between, I think it starts at 0. This is actually 10 divided by 3 is like 3 1/3, so it's bigger than 2 pi. And 2 pi would be 6 pi over 3, so it would have to be, so you got to subtract another 6 pi over 3. So 10 pi over 3 minus 6 pi over 3. 4 pi over 3, so that's how you get that. So just, I'm sure, usually some people just leave it as 10 pi over 3 and move on. Okay, but just want to make sure you subtract it again based upon the directions. All right, anything else off that homework? Okay, I do have guided notes. Let me get those out to you here. This will be the first thing on there. We talked about it yesterday, but I like to hit it again because just radians is something you're not as familiar with as some other, or as degrees. And you need to become more familiar with them as we move forward. Okay. And we're going to revisit that circumference problem again here in 1 second, or a few seconds. Okay, again, radians. Dealing with the central angle, which means the vertex is at the center of the circle. A positive central angle that intercepts an arc of the circle of a length equal to the radius. Okay, so if that length is the same as the radius, then that means the central angle has a measure of 1 radian. Okay. If you would then have 2 radians, okay, the angle would have to have, that arc length would have to be 2r. Now, if you would continue to draw out the arc length, you'd fall a little bit short after 6 of them. That's because the circumference is 2 pi radians. Well, 2 pi is 6.28. So it falls a little bit short. So it doesn't come out to a nice whole number like we would like, but it comes out to 2 pi. So to find an angle based upon the arc length, okay, this formula right here is what we use now. So it goes down on that next little spot underneath there. An angle theta is equal to S divided by R, but that's only, that will give you the value in radians. That'll give you the value in radians. So you find your arc length divided by the radius. Okay, if they're equal, it's 1 radian. If not, it could be 2, it could be 2.5, it could be 3. Now, what happens if I multiply both sides by R, and this is what some of you did on that last one, you get S equals R theta. S will equal R times theta only if theta is in what? Radians. So what you did is you multiply 9 times 120, I imagine, to get 1,080. That's not going to work. So theta has to be radians. And so let's go back here real quick. We know the answer, right? The answer is 6 pi. S equals R times theta. What you got to do is you got to take 120, you got to convert it to radians. So that's why this is one of the reasons. There's a lot of other reasons, but one of the reasons we take a look at, all right, how do I convert degrees to radians? All right, without using your calculators, just using your noggin, what's 120? Think about it in radians. Give you a hint, 60 degrees is pi over 3. 120 degrees, you multiply it by 2, should be 2 pi over 3. So now if I take S equals 9 times 2 pi over 3, multiply 9 times 2, which is 18. 18 divided by 3 gives me 6 pi. So I got to get the same answer. Now, which one's easier? I don't know. It depends on how you look at it. I mean, probably you're multiplying 2 things together. Maybe this one's easier. But if you can't think of the formula or remember it, then it doesn't matter. So here's where we're at, the arc length formula. I give this to you in both forms. In degrees, if you see on there, in degrees, theta divided by 360. You take the fractional part of the circle you have times the whole circumference. And now, in radians, though, it's just S equals R theta. So as you kind of look at things like theta just, or radians tends to just work nicer with like some of the things we're working with. But you're so much less familiar with them that you're just not comfortable yet. So you'll get more comfortable as we move on. I don't care which one you use, depending upon what you're given. Okay, I'm not gonna say like use this formula. Depends on the information you're given. All right, let's take a look at a couple cases here. Find the radian measure. Find the radian measure of a central angle that intercepts an arc of length 12 on a circle of radius 15. All right, you need to draw it out just to kind of have it helps me to have a visual picture of what I'm looking at. This is my angle. My arc length is 12. My radius is 15. It wants the radian measure, so theta equals S over R. Theta equals S, which is 12 over 15. And yeah, you can just divide that, you'll get a decimal, that's perfectly fine. 12 divided by 15 is 0.8, I'm hoping?
Yeah.
0.8. So it's 0.8 radians. Okay. And really, unless we're dealing a lot of times with the unit circle, it doesn't need to be converted to pi. Like you don't try to convert it in terms of pi. This is perfectly fine. All right, that next one down there, a car wheel has a 14-inch radius. A car wheel has a 14-inch radius. Through what angle to the nearest tenth of a degree? So you have to find your final answer has to be a degree. Does the wheel turn when the car rolls forward 1 foot? All right, think about the situation. Take a second or two. Okay, when the car rolls forward 1 foot, you make sure, like you physics people are going to be a lot better at this. You got to make sure your units are the same. So you can't have 14 inches in a foot. So I'm going to make this 12 inches. So it rolls forward 12 inches. That is equivalent to the arc length, okay, because it's traveling along the circumference. So that right there will be 12. Okay, you just kind of wrap it up there. We know the radius is 14. There's your angle. Well, it's easier just use in radians, just to do theta equals S over R. So I'm going to start with that. So theta equals S over R. That means theta equals, my S is 12 divided by 14, which I can reduce to 6/7. Now you can find that decimal, 6 divided by 7, but that's not our answer because that's in radians. What's it want the final answer in degrees. So we're still going to have to multiply that by 180 over pi. So you can't get around it in this case. So the final answer, so theta is going to equal 6/7 of a radian times 180 over pi. Round this to the nearest tenth. Okay, round that to the nearest tenth. And Madison, when you're done, let me know what you get. Seven.
Oh, 7,000. Oops.
Yeah. What you got?
What did you say to round it to?
Tenth.
Is it 49.1?
It is 49.1 degrees. Now, kind of a little bit of a check. 6/7 is less than 1, right? Remember, what is 1 radian equal in terms of degrees? We did this earlier. 1 radian is about 57.3 degrees. So you know it should be a little bit less than that. So that's just kind of a quick check. All right, flip it over on the back. All right, now these type of problems show up in this section. Finding the distance between two cities that are located like north and south of one another. Okay, like on a globe, it has to be like kind of in line with each other vertically to do this. Billings, Montana is due north of Grand Junction, Colorado. Find the distance between Billings, which has a latitude of 45 degrees, 48 minutes, and Grand Junction, which is a latitude of 39 degrees, 7 minutes. All right, we're going to use 3,960 miles as the radius of the Earth. Latitude. Now, I don't know what your background is with latitude and longitude. Latitude is the angle off the equator. Okay. So right here, 30 degrees north means you measure 30 degrees off the equator, and you go to your spot here. So that would have a latitude of 30 degrees. Latitude of 60 degrees north, okay, 6 degrees off the equator. 45 would be here for that. All right, how do we determine the Earth's circumference or Earth's circumference? Earth's radius is 3,960. Anybody know who first did that? No? Well, let me help. Let me tell you. A little history of math here. Well, I won't tell you. But this guy will. Let's see here. While he's loading.
Eratosthenes was the third librarian at
Eratosthenes.
the Great Library at Alexandria.
Did I hit it? Wait. Let's see here. What's going on? Okay. All right.
Third librarian at the Great Library.
He's a great librarian and mathematician. Do the refresh. All right, let's see here. He's killing me. Maybe. All right, here we go. Maybe. I can feel the anticipation.
Now, Eratosthenes was the third librarian at the Great Library at Alexandria, and he made many contributions to science. But the one he is most remembered for began.
Where's my... Ugh.
In a letter that Now, Eratosthenes was the third librarian at the Great Library at Alexandria, and he made many contributions to science. But the one he is most remembered for began.
Ugh. Come on. All right, well, we'll solve the problem and come back to Eratosthenes. We'll solve the problem first. Okay, let's see if that'll work.
The shadow is a sphere. Indeed, the earth is round, but nobody knew how big it was until Eratosthenes got this letter with this fact. So he understood that the sun was directly above the city of Swenen, because looking down a well, it was a straight line all the way down the well, right past the guy's head up to the sun. Eratosthenes knew another fact. He knew that a stick stuck in the ground in Alexandria at the same time.
All right. Oh, no, don't
And the
stop.
same day at
Close enough.
the sun's zenith on the solstice, the sun cast a shadow that showed it was 7.2 degrees off axis. Now, if you know the circumference of a circle and you have 2 points on it, all you need to know is the distance between those 2 points, and you can extrapolate the circumference. 360 degrees divided by 7.2 equals 50. I know it's a little bit of a round number, and it makes me
Why is this not working? Got nothing.
Well, it's November.
Thwarted. And all right, well, exit.
Now, Eratosthenes was the third librarian at the Great Library.
Third librarian.
And he made many contributions to science. But the one he is most remembered for
Not
began
working. All right, we're done with you.
that he received as the librarian.
We'll give it a second. All right, let's solve it. So how he found the radius and circumference of the Earth. Okay, here's what's going on. So yes, we still got to solve this problem. Which one is further north? Billings or Grand Junction? Or you have no idea?
Billings.
So your degree would be further north.
Billings.
Billings, so Billings further north. Grand Junction is here. We're using 3,960 for the radius. It wants the distance between the two cities. That's really an arc length. Okay, so if you think about it, you got a sphere. That's what we're looking for. Okay, so we can find that using these formulas. Now you got two choices. You can use the S equals theta over 360 times 2 pi r. Or you can use S equals r theta. Well, if you're going to use S equals r theta, you're going to have to convert it to radians. It doesn't matter which one you use. It really doesn't. Since everything is in degrees, I'm going to use the first one. We got to figure out, though, that angle. Well, to get to the first one, Billings, is 40, how many degrees? 5 degrees in 48 minutes. And then this one is 39. You're going to have to subtract those two values, and that'll give you the angle between the two cities. Okay. So theta is going to be 45 degrees, 48 minutes, minus 39 degrees, 7 minutes, which is 6 degrees, 41 minutes. So that gives me the fractional part of the whole circumference I'm working with. So out of 360 degrees, I only have 6 degrees. So S equals 6 degrees, 41 minutes divided by 360 times 2 pi times, what do we say we're using? 3,960. 3,960. And now just use your calculator, the 6 degrees, 41 minutes. You can hit 6-second angle degrees, 41, using that angle menu, minutes. Where'd it go? There it is. Okay, and if you hit enter, it'll give you the decimal. Divided by 360. So that's the fractional part of the circle we have, times 2 pi times 3960. And I'm nearest miles fine for this. There's 462. So S equals 462 miles. Okay, 462 miles. So it's basically an arc length problem. Now, if you want to do S equals R times theta, you've got to convert theta to radians, multiplied by pi over 180. Okay, for that. All right, now let's see here. Okay, there is the assignment. I'll see if I can get my story back up, because I know you are interested. I know you are. There's the assignment over there. And let me see here. And I'm going to stop recording.